All right, so here we are on day 5 homework. So let's take a look at what we're supposed to be doing for 1 and 2. We need to make sure that we're identifying the values of x, completely explain our reasoning for why we choose those values, and leave your answers in interval notation. So we're looking for where the intervals where the g function is less than the f function. So and then number 2, we're looking for where the g function is greater than the f function. So answer those questions. All right, and then so if the g is less than the f, then the graph of g of x is going to be below the graph of the f function. And here, the graph of the g function is going to be above the graph of the f function. So if we were to take a look and notice that the g function is the dashed line, we're looking for where the dashed line is below the solid line. So remember, we can only compare on the intervals where they have overlapping values. So we can only compare from here to here. All right, so this is the only interval where both graphs happen to be coexisting at the same time. So this would be the region for that. We've got -7 to -6. And then the next time when the dashed is below is from 6 all the way to 10. And then here the dashed is above the solid from -6, again, not including because I don't have the equal to symbol. So we've got -6 all the way to 6, and then not or because we want interval notation. All right, so now we're asked to do number 3. So we're looking for the x where the f function is equal to the g function. And then on this one, where the g function, the dashed line, is equal to 0. So here is the reasoning for that. Remember that when the two functions are equal, the graphs are going to be intersecting. So we're looking for where those intersections occur, which is going to be right here and right here. So those are very specific values of x. Then we're looking at where the dashed line has those x-intercepts, where it's on the x-axis. So we can see that the dashed line is going to be here and then also here. So let's take a look and see those values. All right, now let's take a look at number 5 and 6. So think about this for a minute. In order for you to multiply and get a positive, which is that's what that's saying, both the y values of the g function and the f function both have to be the same sign. So if they're both positive, when you multiply them, you're going to get a positive. If they're both negative, you're going to get a positive. And then in this case, they're going to have to be opposite signs. So that means they're going to have to be on opposite sides of the x-axis. So we can take a look at the explanation. So we're looking at the same side of the x-axis. So that means they're going to be positive if they're on the same side, or both negative. And then here's opposite sides of the x-axis, which means one's going to be a positive, one's going to be a negative. So if we take a look at your graph, if I try to zoom out here for a minute, we're looking at the same side. So we can identify where the solid and the dashed are above the x-axis. And then we will look for opposite sides. So let's take a look. -7 to -5. So -7 to -5, you can see that they are both above. After -5, we dip down, so we can't include that. The next time when they're both above is going to be from -3 all the way to 1, and then from 4 all the way to 10. And then now when they're on opposite sides, so from -5 to -3, you've got one that's below and one that's above, and then from 1 to 4. So the trick here is to identify where the x-intercepts are, and then look at where the functions are in between those x-intercepts. And then it'll be pretty easy to see. All right, so let's go and take a look. All right, so here we go with the next page. Try to focus in on that. All right, so we've got, we have the function of f and then a table of g. So on number 7, we are asked to calculate this value. So remember that we needed to keep our values f of -1, f of -1. So -1 is going to give me a 2 minus 2 times g of 1. So in the g function, when x is 1, my y is -5. And now you need to do PEMDAS. So again, when we do PEMDAS here, we've got -4 plus 10. We've got 4 and we've got 6. And so we get 24. Now on 8, it says if p of x is equal to this function, then for what values of a, so we're solving for a, is p of 2 equal to f of 1 minus g of -2. We have to first figure out what this is. So p of 2 is equal to f of 1, which is going to give me a -2, minus g of -2 is a 4. So p of 2 is equal to -6. So this translates into an xy coordinate. Okay, so that means I now can take my p of x. Okay, so my p of x, which is the y coordinate, is -6, is equal to a. My x value is 2. And now I have an equation in which I can solve for a. So -6 is equal to 4a minus 6. I'm going to add 6. I've got 0 is equal to 4a. Divide by 4. A is equal to 0. Okay, so let's take a look at that. And again, we've got making sure that we understand how we got to that process. All right, so now this is very important. Again, we are identifying the intervals on which the graph is increasing. Remember parentheses, and then we've got decreasing, parentheses, and then constant, which is that horizontal line. So if I take a look at increasing, my increasing is going to be from -5 all the way up to 4, also from here to here. So I'm going to highlight the interval where the graph is increasing. Then the decreasing, the decreasing is going to be from here to here, and I do not see any horizontal line. So let's take a look at those intervals, make sure we agree with those. All right. I would say, yeah, this looks like it's 5 right here. So -5 to -2, and then from 1 to 2, and then from -2 to 1, and then from 2 to infinity. And you could have simply written none for where there is no constant.